Hey everybody, it's Mr. Carr again. Today we're going to be talking about 7b day 2, multiplication of polynomials. Okay, so when we do our multiplication of polynomials, we actually are combining some of the exponent properties that we've done before. Okay, so we multiply a polynomial by a monomial, and I really want to just say this first. Whenever we multiply different size polynomials, what we're really doing is distribution. Okay, so it's kind of interchangeable for what our goal is here. We are distributing, we are multiplying, same idea. So we're going to start with the multiplication of a monomial. When we do this, everything gets multiplied by that monomial. So we're going to have 2x times 6x squared. If it helps, go ahead and write it as this. Okay, and we got a minus here, so it'll be minus 2x times 3x. Seeing it this way might help you do the multiplication a little bit easier. This we've done in the past. We just did this in 7a. I've got 2 times 6 is 12. X times x squared is x to the third power. Okay, over here I've got 2x and 3x. That's going to give me a minus 6. And then x times the second power, that's x squared. For the second step, it says to simplify. That's just checking for like terms, see if there's anything you can do there. I don't have any like terms here, so we're going to move on to the next problem. So we're going to take 6y and distribute that to everything. So I've got 6 times 4 is going to give me 24y to the third power. 6y times a negative 9y is going to give me a negative 54y to the second power. And then 6y times a negative 7 is a negative 42y. Notice I didn't do this step here. Only write that down if you feel like it's helpful for you. So that would just be me taking each of these written out, like 6y times that, 6y times that, and that 6y times that. All right. Double check, is there a simplification? Nope. We got 3, 2, 1 for our degrees. So we're good. Here, I'm going to go ahead and distribute the 3t. So we got 3 times 2 is 6, t to the third power, and then negative 12t squared minus 45t. Here, I'm going to do another distribution with the 6t. So that means 6t times 5t is going to give me 30t squared. 6t times 2 is going to give me a positive 12t. Now I can combine like terms. So I'm going to do the next step to simplify. Okay, this one is only t cubed, so I'm good there. I got negative 12t squared, positive 30t squared, and then I've got a negative 45 and a positive 12. So we're just going to combine these. So 6t to the third power, positive, that'll be 18t squared, and then a negative 33t. Okay, so we can also multiply binomials. So we're going to do 2 binomials multiplied together. When we do this, we do have to be careful because I'm still going to use the term distribution. What I'm going to do is I'm going to take the y, y is going to be multiplied by both of those. So it looks like this, y times y, and then minus y times 4. Okay, but I'm also going to be taking 8 times both of those. So it's going to be a positive 8 times y and a positive 8 times a negative 4 there. Okay, so that's what my distribution looks like. And really, I'm going to kind of add in a little bit here because lots of times we kind of see it more like this first before I do any of that. Y is being multiplied by y minus 4. And then also a positive 8 is multiplied by y minus 4. That's really what's happening here. Okay, you don't have to write all these steps down. If you can kind of just go off of this little rainbow method, some people like to call it, go ahead and do that. I'm just showing what's happening. So I'm taking y, the first y here, multiplied by the entire expression y minus 4. 8 being multiplied by the entire expression y minus 4. Then this is what the next steps would look like. You don't have to write all these down. I'm just showing you. So y times y is y squared, negative 4y, positive 8y, negative 32. These two can come together. So I got negative 4 and a positive 8. So that's a positive 4y minus 32. And that's it. I'm going to show a slightly different method. Kind of the one I prefer to do on here. But let me pause real fast on that one. Okay. So when you do the multiplication here, I like doing what's called a box method. I have a binomial and a binomial. This really fits on the outside. If I look at the outsides of this little, some people call it Punnett square, I'm going to represent my multiplication as like this box. So I put both of my binomials on the outside, and I'm going to multiply these 4 sections. Each of those sections are going to be like multiply with the 2 things there. So for example, 2x and x make 2x squared. 1 and x come together as a 1x. 2x and 6 come together as 12x, and then I'm left with a 6 and a positive 1. 6 times 1 is going to give me 6. The nice thing about this one is you can kind of see very easily what goes together. Those are my like terms. So 2x squared, 12x and 1x are going to make 13x, and a positive 6 at the end there. I don't care which method you do. You want to do this, you want to do a box method. I'm just like showing it because me personally, I like the box method. It's nice and organized. It makes sense. If I decide to make this like 3 terms, then I would make 2 and I would add another column here to make it a 3. Okay, so just depends on what you're working with. Example C, a patio in the shape of a triangle is being built. The dimensions given are in feet. The area of the triangle is area equals 1/2 base times height. So base is this one, height is this one. Write the expression for the area of the patio. Not really a realistic word problem, but we're gonna go with it. So we're gonna take 1/2 times the base, which in this case is 6x plus 7, and then times x minus 7 for the height. That's our start. My next thing I'm gonna do is I'm gonna go ahead and do my distribution first of the 2 binomials. I like to multiply that first before I try to do the 1/2 to everything. So I'm gonna take 6x. Like I said, I like the box method, so I'm gonna set this one up. Okay, so 6x times x is 6x squared, 7 times x. 6x times a negative 7 is a negative 42. 7 times a negative 7 is a negative 49. So a is equal to 1/2 multiplied by this whole trinomial, 6x squared, 7, whoops, forgot to put an x there. Positive 7 and negative 42 is going to give me a negative 35x minus 49. Okay, from there, I'm going to do one more distribution, and that's going to be taking 1/2 multiplied to everything. So it's going to give me 3x squared, negative 17.5x, and then a negative 24.5. All right. Multiplying polynomials. Here we're going to do our we're going to be doing our binomial times a trinomial. Okay. So again, this one you can do, like for example, 3a times that, 3a times that, 3a times that. That's fine. I'll do this times this times this. I'm going to show the box method on the next one. So 3a times a squared is 3a cubed. Then 3a times a negative 12 is a negative 36a, a squared. And then 3a times 1 is a positive 3a. Okay, 4 times a squared is a positive 4a squared. That'll be 4 times a negative 12 is a negative 48a. Positive 4 times positive 1 is a positive 4. Now I'm going to look for those like terms. I've got a squared and a squared, a, and that's it. So 3a cubed minus 32a squared, not plus, it'll be minus 45a plus 4. Okay, there's my simplified. For part B, I'm going to do this. That's 3 terms and 2 terms. So for my box method, I'm going to do a 3x2 box. Okay, I've got 4z squared, 3z, and 5, 3z, and negative 2. Write that one a little better. Okay, 3z and negative 2. It's 3 terms and 2 terms. I make a 3x2 box. Okay, from there, we're just doing each of those little areas basically. So 4z squared times 3z is 12z cubed. I put an x there, should have been a z. 3z times 3z is 9z squared. 5 times 3z is 15z. 4z times a negative 2 is a negative 8z squared. 3z times a negative 2 is a negative 6z. And then 5 times a negative 2 is a negative 10. I'm gonna highlight here because I'm running out of space, but we got these go together, and we got these two going together, and that's it. It's already organized pretty neatly. So 12z cubed, 9 minus 8 is a positive 1z squared, 15 minus 6 is a positive 9z, and then minus 10. All right. Special cases, and these are the last couple examples we're going to go over. So special cases, multiply these together. The thing to remember is when I'm multiplying this and I'm saying that's to the second power, you need to remember it's this. I am multiplying two binomials together. Okay. When I do this, I'm going to take 2x times 2x, 2x times 7. So it's going to be 4x squared plus 14x. 7 times 2x is going to give me a positive 14x again. 7 times 7 is a positive 49. Put these together and I get 4x squared plus 28x plus 49. Okay, so there is a pattern with this. This is called, whoops, oh, that's a bad line. Okay, so if I'm looking at, if I call it a and b squared, all right, and so a plus b squared, we got the sum of these two like that. It goes to this pattern of a squared plus 2 times ab plus b squared. So you look at my final answers, started with 2x here for in that a position. If I take that multiplied by itself, I get 4x squared. Okay. If I take 2x times 7, that's 14x, multiply that by 2, and I get the 28x here. And then b squared is just the 7 times the 7, which is the 49. Okay. So that's a kind of a pattern. If you kind of recognize that, you can use that a little bit easier if you want. The other special patterns, we look at this one. Notice how the only difference is the positive and the negative. So watch what happens when I multiply this out. 3x times 3x and 3x times 7. I get 9x squared plus 21x. Then negative 7 times 3 is a negative 21x. Negative 7 times 7 is a negative 49. Yeah, positive 21 and negative 21, they actually cancel each other out. So I'm left with 9x squared minus 49. All right. So that's simplified kind of nicely. In fact, it has this kind of a pattern. If I'm multiplying two binomials, and all I do is I just take the opposite of that b value, it's always going to look like this, a squared minus b squared. Okay, so these are just some of our special cases. They have their own little patterns. They're helpful. They're shortcuts, but you don't have to use them. You can still just do the full distribution there. Again, kind of a lot going on here, but bottom line is we're trying to understand how we multiply polynomials. Big keyword today, distribution. Okay, make sure you're using distribution when you're trying to multiply through. After that, it's just a matter of combining like terms and simplifying when you can. Okay, that's it for today. Take care, everybody.